Here's a solution to chapter 3.5, problem number 5 from the textbook. So we start with a non-contextual example here with two box plots, each using the same scale, so a different story is being told in each. What we need to remember about box plots are created, right, by 5-number summary. So important information we need to know. We need to know what x1 is equal to. We need to know what the median is equal to. We need to know what x3 is equal to. And then we also use min and max as part of, so those become the middle, and then you have the min and max on the side. So just by looking at this, we can see, identify, here's a min, here's a max. Q1 is going to be here. The median is here. So let's use the right colors here. Here's a Q1, here's the median, here's a Q3 in terms of the location. So we can then come down the x-axis and take a look, and then the max. And so looking at the first question for question number A, letter A, to the nearest integer, what is the median of variable x? So we have some variable. Median is going to be in the middle. So we're going to say about 40, since it's in the middle there. The median, the box, represents the middle 50%. For B, to the nearest integer, what is the third quartile of variable y? And so looking at these here, here's quartile 1, here's the median, here's quartile 3, and again, here's the minimum value, and here's the maximum values there. And so the answer for B, what is to the nearest integer, what is the third quartile of variable y? It's going to be here, the third quarter. Remember, this is 25%, this is 25%, and here's 25%. Here's the rest, so that's your 100%. So we're going to say about, I would say about 52. And then for C, which variable has more dispersion, and Y dispersion? In this case, this means spread out. Which one has more spread? And it looks like variable Y has more spread. And you can see it has, it's more spread out. Maybe um, use the range to estimate the spread, right? And you can see it's a bigger range from 0 to 110 versus from like 15 to 60. So variable y has more spread or dispersion. Looking at question D, describe the shape of variable x. And so in our notes somewhere we had seen the spread. So if we wanted to look at the notes real quick, let's see if we could find it. In our notes from chapter 3, 3.5, there's a picture that I gave you that right here, it tells you the type of shape depending upon the shape of the box plot tells you the shape or distribution. So you can see we have those different shapes. That's the 3.5 notes. Come back to the solutions here. So looking at this, what is the shape of variable x? I would say variable x has, it's symmetric, or you could say bell shape. Bell shaped, I think we would go with that one. Um, and then E, what is the shape? Because there's symmetry here, right? There's symmetry in this in that. And then here, what is the shape? I would say skewed right. We're skewed right here because you can see there's a long tail here. There's a long tail on the right. So there you go. Okay, here's problem 9 from the homework, chapter 3.5, number 9. Chapter 3.5, number 9. So let's go ahead and look at that one now. And so the question is, we're asked to find a 5-number summary from all this data. This data has the age of the U.S. presidents all the way through Barack Obama, the ages of presidents. And so we're interested in understanding the distribution of that. And so we're not going to do this by hand. There's a lot of numbers there. It's 45, 46. I think it's 45 different presidents there. We want a 5-number summary, construct a box plot, and then describe the shape. Best way to do that would be StatCrunch. You can see if you go to the online textbook, you'll be able to pull up, that would insert the data for us. So looking at that there, so this is the problem. You just click on that button there. StatCrunch will open up. The data is there. So first thing we want to do is create a 5-number summary. And so for the first things, we're going to do summary statistics, president, age, and inauguration. And then you just go ahead and get your 5-number summary. There you go. Min, max, and the last one is median somewhere. There it is. And so you have your 5-number summary, compute, and then you have your values right there. So there's your 5-number summary that we're looking for. And so let me copy and paste. So there is what you're looking for there. And let's paste that in, and then we'll do something with that. And so from there, your 5-number summary, you have your Q1, Q3, Q2 is the median, min and max. So then you have that answer there for your 5-number summary there. So there's your 5-number summary. And then what do you do with the 5-number summary? There it is. There. So there's your 5-number summary. And then what you do with the 5-number summary is then construct a box plot. We can do that by hand. Draw a graph there. And let's distribute. It goes from like the 40, so we can just basically make a number line. So here's 30, here's 40. And again, this is somewhat arbitrary how you do it. 60, 70, and then we can make a box plot. The min value is around 42, so we put a dot there for the min. Max is 69, so we put one there. Q1 is quartile 1's 50.5, so there's a point here. Q3 is 57.5, so here. And so then this forms your box. Your median is 54, somewhere here. And then we draw your whiskers. There's your box plot. That's it. If we wanted to use StatCrunch to kind of verify that, you would just go to StatCrunch, graph, box plot. Here you go. I like to do that there, and then compute. And so you can see it's very similar to what we got there. And the shape looks pretty symmetric. I would say the shape looks symmetric. So let's go ahead and answer those questions. And so for number 9 there, we have those number 9, we construct a box plot. There it looks there, and then there's our box plot. We saw it in StatCrunch, describe the shape. So this is B, this is A, and then C, the shape looks symmetric. Right, it looks the same on both sides. It's about symmetric, so you would say, because the median is in the center right here. There you go. Before we go on to problem 16, I think a quick question we might be interested in, are there any outliers? And so we'll do that by hand a little bit in the next one. But on this one here, we could check to see if there's outliers on StatCrunch. When you made this here, you click that there, use fences to identify outliers to see if there's any, and there turns out to be 169 is an outlier in this case using that information. We'll end up looking at that in the next problem, but 69 would be considered an outlier from using StatCrunch here. So looking at that, I would say 69 when making that out, there's an outlier. So that might be something, well, for sure something you want to be able to do. Okay, let's look at problem 16. This is from chapter 3.5, number 16. And so we want to compare chocolate chips from 2 different companies, Keebler chocolate chips versus just kind of your generic store brand. You want to know, is there a difference, right? To find out, you randomly sample 21 cookies from each brand to see if there's a difference in the number of chocolate chip cookies each brand gives. And so one way to do that would be through box plots and then looking at the distribution to see if one is more consistent with the other. And so again, that's problem 16. So the best way would be to get that data um, from your textbook entered in. So let's go ahead and open StatCrunch for that. Let's have it. So the data would be put in. And so we want to make box plots of those two. Let's go ahead and draw them. Let's see the distribution. So then you can kind of see what we have here. And so you have these distributions for Keebler and the store brand. And then we can go ahead and discuss those. I'm going to go ahead and copy that into our notes. And so I've copied now those box plots we created using StatCrunch. So now they're side by side. So we now have both box plots here. You can see there's a difference. The store brand has more dispersion here. You can see it's wider spread out. There's more spread here. So that's an important question to be able to, an important characteristic to observe is that there's more spread. It's more spread out compared to the Keebler brand. There's less spread. And so here's your part A. There's your side by side. StatCrunch did that for us. It has the medians, min, max, Q1s, Q3s. Does there appear to be a difference in number of chocolate chips? I would have to say, if you're thinking about it, looking at that, I would have to say yes, there is a difference. And I think so. The answer is yes to me. And in order to really solidify that, I think we're going to look at you would look at the spread. What's the spread of each of those? And so we can see in this one here, as you look at the side by side, yes, there is a difference in the number of chips. I think Keebler has its median is a little bit higher right here. Has I think a greater median value. I think that's one thing to look at. A greater median value. The next thing would be you could also look at which this means there is again more chips in general on average. This middle 50%, right, compared to this middle 50%. You're on average, I think you get more chips from Keebler. Does one brand have more consistent number of chips? Consistent number of chips here. And for part C, I would say, yeah, there's a brand that has more consistent. I would say Keebler appears to be more consistent. Um, and again, one way to do that, you see a shorter range. There's one way, shorter range, right? It has smaller range compared to this one has more range. So we have problem number 20, chapter 3.5, the last problem from the written homework. Which box plot likely has data that has a larger standard deviation and why? And so again, that standard deviation there is another word for spread or dispersion. Is a way to think about it. And the other thing that, so when we're looking at that, we're going to look kind of another kind of way to approximate that would be with the range a little bit. And so I think on this case, looking at this is like 7 and this is like 22. This number here is like 12 and this one is like say 25. And then you see here the IQR is bigger here for this one. The IQR is bigger in variable 2. So I think looking at that, it's important to consider. So I would say box variable 2 likely has a higher standard deviation. And that's again because the range is a little bigger and the IQR is bigger, which means it has more spread around the middle. So that's what we would go with.